Okay, so the second case that we need to consider is the case when the discriminant of the quadratic form is positive, so which means that the um, the quadratic form itself has two distinct real roots, right? So in this case, um, a z square plus b z plus c is essentially a times uh, z minus lambda 1 times z minus lambda 2, right? And when we, integrate um, this minus lambda 1 z minus lambda 2 dz, we need to do the partial fractions, right? So it's going to be a partial fraction decomposition. So essentially it's 1 over z minus lambda 1 plus 1 over z minus lambda 2. I guess it should probably be minus, right? Or maybe this was minus, this was plus, doesn't matter. So in this case, if I do this, then I get z minus lambda 1 minus z plus lambda 2, right? Yeah, so I guess, so it means that z and z are going to cancel. So I need to divide by, so basically I need to divide this thing by 1 over lambda 2 minus lambda 1. All right, so and then I'm going to integrate these two forms separately. And this is how I'm going to get a sum of logarithms, right? So, but again, long story short, so here is what we do, and in this case, we're going to get uh, a logarithm of the ratio in the final answer, and then again, so we need to equate this to minus x plus d0, and then we need to recall that z is really y prime over y. And again, so after a long and complicated calculations, and the most complicated part being dealing with the absolute value sign, so because we always need to think what is an arbitrary constant, what is a positive constant, what is a negative constant, and so on, right? So in the end, we are going to get this. Okay, so let me just uh, skip forward. So if you're interested, you can just read the slides carefully. But conceptually, there is nothing difficult here. It's just that it's a long, very, very long calculation. And in the end, we are going to obtain the general solution as as we expected it to be.